Hi, today we discuss bond length, bond angle, bond order, bond enthalpy. Let's we start first of all bond length. Definition of bond length is the equilibrium distance between the center of the nuclei of the two bonded atoms is called bond length. See here two atoms. The distance between the two nuclei is called bond length. Here atom 1 nuclei, atom 2 nuclei. Here distance is called bond length. Okay, R1, R2. R1 plus R2 is equal to bond length. In general, the larger atoms involved in bond, the longer the bond length. And the more bonded between two atoms, the shorter bond length. Understand? The larger atoms have bond length is larger, and in between atoms bond length is bond more bonds in between atoms, the bond length is less. We see in CC bond length is 154 in between single bond. In CC, in between two bonds have 134 pm bond length. In between CC, in three bonds is there, the bond length is 120 pm. Okay. See some more examples to bond length. Next we move to bond angle. A bond is formed by the overlap of atomic orbitals. The direction of overlap gives the direction of the bond. The angle between the line representing the directions of the bond, that is the orbital containing the bonding electrons, is called the bond angle. C is a CH4. Bond angle is 109 degrees 28 minutes, and here NH3. Bond angle is 107. H2O 104.5 degrees. BF3 120 degrees. Next we discuss bond order. Bond order is the number of bonding pairs of electrons between two atoms. To calculate bond order, we have a formula: number of electrons in bonding molecule minus number of electrons and in bonding molecules divided by 2. We get bond order. Bond order is the number of chemical bonds between a pair of atoms and indicates the stability of a bond. For example, in diatomic nitrogen, N triple bond N, the bond order is 3. In acetylene, C2H2, the carbon-carbon bond order is 3 and the CH bond order is 1. Okay. Next we move to bond enthalpy definition. Bond enthalpy, also known as bond energy, is defined as the amount of energy required to break one mole of the stated bond. For example, the bond energy of a OH single bond is 463 kilojoules per mole. This means that is required 463 kilojoules per mole of energy to break 1 mole of OH bond. Bond enthalpy usually expressed in kilojoules per mole. Greater the bond dissociation enthalpy, greater the bond strength. For diatomic molecules like H2, Cl2, O2, N2, HCl, HBr, HI, the bond enthalpy are equal to their dissociation enthalpy. In the case of polyatomic molecules, bond enthalpies are usually the average values because the dissociation energy varies with each type of bond. In H2O molecule, first OH bond enthalpy is 502 kilojoules per mole and second bond enthalpy 427 kilojoules per mole. Average bond enthalpy is 464.5 kilojoules per mole. Thanks for watching. Please like, share and subscribe.